Hi, my name is Azim Polat, and this is my screencast for Project 3 File Systems Implementation. The core structure for this project is a tree that models the WAD archive as an n-ary tree. I used a simple tree structure called WAD tree, where each node represents either a file or a directory. Each node stores its name, offset, and length, and a type flag to indicate if it's a directory, and a vector of its children if it's a directory. And let's look at wadtree.cpp file. The constructor sets the root pointer to null. The destructor handles cleanup of the tree. The tree uses post-order traversal during cleanup, so all child nodes are deleted safely before their parent. And we have init root function. This initializes the root node of the tree as a directory named /. It returns the pointer to the root node, which we use to start building the tree. Then we have add child. This adds a child node under a given parent. It takes the name, offset, length, and directory flag as input, then pushes the new node to the parent's children vector. This is my WAD class. It handles reading the WAD archive file, building the in-memory tree, and managing the descriptors. The WAD file header stores the magic string, the number of descriptors, and where the descriptor block begins. The path lookup table is an unordered map from full path strings to node pointers. This avoids deep traversals when searching for nodes. These are the main functions: loading the WAD, getting the file metadata, reading contents, listing directories, creating files and directories, and writing file data. There's also a helper function to find where the descriptor lives in the WAD file. Now let's take a look at the implementations of these functions in WAD.cpp. The constructor opens the WAD file using POSIX system calls. It reads the 12-byte header first, the magic, descriptor count, and descriptor offset. Builds the in-memory tree by parsing the descriptors. It uses regular expressions to detect map directories and namespace directories by matching descriptor names. Adds each node to both the tree and the lookup table. For map directories, it uses a helper function to handle their special structure and children. Handle map directory. Handles parsing for map directories. Adds the map directory and its 10 child files to the tree and lookup table. The destructor closes the file, clears the lookup table, and resets the header values. The actual tree cleanup happens in the WAD tree destructor, which we looked at earlier. Get magic, a simple getter, returns the WAD file's magic string, like iwad or pwad, is content, and bool is directory. Check the lookup table to see if a path points to a file or a directory. These are quick checks using the is directory flag on the node. Then we have get size, returns the length of the file at the given path. If the path is not a file, returns -1. Get contents, reads file contents into a buffer. Handles offset and length to make sure reading stays within bounds, uses lseek and read system calls. Then we have get directory. It lists the names of immediate children under a directory, populates a vector with these names, returns the number of children found. Create file, adds a new empty file, writes the file descriptor into the WAD, either at the end of the root or before the parent's end, prevents duplicates and invalid names. Create directory, adds a namespace directory, writes start and end descriptors, uses descriptor shifting if the parent is not root. Write to file, writes file contents into the lump area, only writes to empty files, backs up the descriptor table, writes the data, restores the table, updates descriptor offsets and lengths. Find descriptor offset, which tokenizes the path, traverses descriptors to find the correct location, handles namespace markers and map directories. Now let's take a look at my daemon. Daemon handles reading, writing file and directory creation, metadata retrieval, and directory listing through the fuse callback functions. Get attribute, retrieve file or directory metadata, maps directly to WAD libraries, is directory, is content, and get size functions, and make not creates a new file with touch or CP, handles file creation, calls create file from the WAD library to add new file descriptors. Make there handles directory creation, calls create directory from the WAD library to insert namespace descriptors. Read operation reads file contents, calls get contents from the WAD library to read lump data. Write operations handles writing into files, calls write to file from the WAD library. Read directory lists contents of a directory, calls get directory from the WAD library to retrieve children names. And destroy operation deletes the WAD object and frees the memory. It supports cleanup when unmounting file system. And registering the fuse operations, and this is the main function. It parses arguments and launches fuse with the WAD object, uses example logic from discussion slide. And that is the walkthrough of my source code. Now let's move on to testing. We will use Ernesto's test script. My library implementation passes all 35 tests. Now let's build the daemon by executing the makefile. As you can see, the files are there.